Assalamu alaikum. My name is Rizwan Shahid. I've made even parity bit generator and its checker. Okay, here I have made logic circuit also, because in the hardware the circuit is not clearly seen because of the bunch of wires I have added in the circuit. But by this diagram I will try to make everything clear. Okay. Now this logic diagram is of 4-bit even parity bit generator. It means it accepts 4 input bits. Okay. Same goes for our hardware. Just the difference between uh, this and this is that I have used here the ICs and here are gates, and we know that each IC there is 4 gates. Okay, means that this first one IC there are for 4 gates, this one IC for 4 gates, and this one IC 4 gates. And the IC I have used here is 7486. It means it's an XOR gate IC, and we know that the logic of XOR gate is that if there are different inputs in different input, the output is always high. Okay. Now overviewing my hardware circuit, this is my source, as I am providing VCC to the IC. Okay, XOR IC, and this LED, these two LED are transmitter LED. It means they will generate an even parity bit. Okay, by looking at the input, they will generate the even parity, and this is the checker of IC. This is the checker LED, and it will now we know that what is the function of checker. The function of checker is that to see if the even transmitter have generated a correct even parity bit or not. If not, then it will goes to high, and this LED will glow. Okay. Now come back to our logic diagram. I have separated these two circuits with the help of lines in order to tell each thing clearly. Okay. Now if we see the logic, I have passed 4 bit input through XOR, and the output of that were further again held as input to another XOR. Okay, and this XOR is called will generate our parity, even parity bit. Okay. Now in logic diagram I can see that I've made two circuits, and which are bounded in two box. This is box 1 and this is box 2. They are same circuit, as we can see that box 1 is the mirror of box 2. Okay, and I have made this circuit only because check to give checker input. Now in hardware, this is my box 1. Okay, each IC, this one IC is my box 1 whole, this one IC is my box 2. Okay, this one IC is my box 2, and this is my checker IC, which will generate a checker. Okay, this will verify the circuit is correct or not, generating even parity bit. Now the output of this box 1 and box 2 circuit is given as input to the checker. Okay, and this is my checker, as you can see, and in hardware this is my checker. Okay. Now in order to check my checker, I will give 4-bit input in box 1. Okay, 4-bit input 1010 input in one box, and second box 4-bit input, and which both are different from each other. And I have done this action deliberately, because if they are different, it will provide 0 1, and our checker will glow. Okay, same I have done with my circuit, and I have done 1010 here, and 0010 in second box. Okay, and I've already told you that this is my box 1, this is my box 2, and let's see that my checker will glow or not. And by just doing this, I can see that my checker is going bright. It means that this is my even parity bit generated is not uh, correct, and checker goes high. Now further I will check. Now I will check my transmitter LED that it is working properly or not. I have applied odd ones input in odd, okay, to the XOR, to our circuit, box 1 circuit, and same goes for our box 2 circuit. Here ones are odd, and now we know that parity bit transmitter will generate 1 2. It means that it will show that this input is odd and we have to add 1 in it to make it even. Okay, now we will see. I have set up same A B 0 0 1 0 0 0 1 0 here, and 0 0 1 0. I have told you that this is my box 2. This is 0 0 1 0, and here same goes for our hardware. And now I will see that if my transmitter will generate high or not. As I can see that my transmitter generates high, and it needs to add 1 in our input to make it even. Okay, now that's all from my side. I've tried my best to make everything clear. Hopes I like this. Love is.